Hello, welcome to this lesson in the chemistry tutor. In this lesson, we're going to talk about Charles's law. And so if you remember, in the last couple of sections, we talked about Boyles Law, and Boyles Law dealt with how pressure and volume are related to one another in chemistry. But in this section, we're going to talk about Charles's law, and that is going to relate how volume and temperature are related in chemistry, gases, when all other things are constant. So if you remember, I told you that there's only a few things that can totally govern and explain how a gas behaves. I'll write it over here, the pressure, the volume, the number of moles of the gas, and the temperature. These four things are basically completely descriptive of the state of the gas, okay? They're actually called state variables. So this is pressure, volume, the number of moles of the gas, which means how much of the gas you have, and its temperature. You don't need anything else to describe how the gas behaves. Now, for Boyles Law, before, we basically held these two constant. We said the amount of gas, number of moles is constant, and the temperature is constant. Let's see how P and V are related, and we figured that out last time. In this section, what we're going to do is we're going to figure out how V and T are related to one another. And so in order to do that, we're going to hold the pressure constant. We're not going to let that change, and we're going to also continue to hold the amount of gas, the number of moles of the gas constant. So when you hold these guys constant, we want to see how the volume and the temperature of a gas are related to one another. So the discussion kind of proceeds very similarly as it did for Boyles' law, but this guy is called Charles's law. And I'll write it down in words just like we did for Boyles' law, and then we'll talk about it. So at constant pressure, okay, the following is true. The volume of a gas, and by the way, when I say the volume of a gas, when I'm talking about a gas in these laws here, I'm talking about the ideal gas, the perfect gas. Real gases like oxygen, hydrogen, they're not totally ideal. So these equations that we're using are not 100% accurate, but they're definitely close enough for most work, certainly to understand the big picture relationships. As we get farther down the road, we'll learn about how gases cannot be totally perfect. We'll talk about the reasons for that later, but we talk about gases in these laws here. We're talking about perfect ideal gases. But anyway, the volume of a gas varies directly with the gas temperature in Kelvin. Okay, now if you haven't used Kelvin too much in chemistry, I'll remind you on how to convert between Kelvin and Celsius, and I'll explain a little bit more about what Kelvin temperature is. But for now, just if you haven't used Kelvin too much, just think of it as another measurement, much like Fahrenheit is a measurement of temperature, Celsius is a measurement of temperature. Kelvin's is just another temperature scale. I'll tell you why it's important in a minute. But when we're talking about these gas laws, and generally when we're talking about gases in chemistry, T, the temperature, we're going to be using Kelvin, usually when we're doing the calculations. But let's see how this reads. At constant pressure, notice we're going to hold this pressure. It's also implied we're also holding the number of moles of the gas constant. The volume of the gas varies directly with the gas temperature in Kelvin. So if you remember Boyles' law, the relationship varied inversely, right? And we saw what that was like in the last couple of sections. Here, it's not varying inversely, it's varying directly. And what does that mean? It means in math that the volume of this gas is proportional to the temperature in Kelvin. Now remember, for Boyles' law, on the right-hand side you had 1 over something. That's an inverse relationship.